Buffer solutions are those solutions which resist the change in pH due to addition of small amount of an acid or a base. There are two types of buffer solutions: acidic buffer and basic buffer. Now, these what are the why there are two types of buffer solution? If you have to maintain the pH in the acidic range, then you will have to use the acidic buffer solution. If you have to maintain the pH in the basic range, then you will have to use the basic buffer solutions. Now, how the acidic and basic buffer solutions are prepared? For acidic buffer, you will have to take a weak acid along with its salt, or you can say along with its conjugate base. If you have to prepare a basic buffer solution, then you will be taking the weak base and its salt or its conjugate acid. Examples of buffer solutions are carbonic acid and sodium bicarbonate. Another example is acetic acid with sodium acetate. Third is ammonia with ammonium chloride. Now we'll see about acidic buffer solution. So these solution maintains a pH between 4 and 7. These can be prepared, this we have already seen, these can be prepared using a weak acid and its conjugate base. Let's take the example of our acetic acid and sodium acetate. So when you prepare, you are taking an aqueous mixture. So when acetic acid is present in the mixture, when let's discuss the acidic buffer solution. These buffer solution maintains a pH between 4 and 7 and can be prepared by using a weak acid along with its conjugate base. Let's take the example of an acidic buffer solution: acetic acid and sodium acetate. So acetic acid, when present in a aqueous solution, it dissociates to a very smaller extent into uh, acetate ion and proton ion. And similarly, when you have sodium acetate, it's a salt, so it will also be dissociated into acetate ions and plus sodium ion. Now let's see what happens when a little amount of acid is being added. So when you add an acid, so this equilibrium will shift to the left hand side, that acid, and that can be explained on the basis of common ion effect. As soon as you add a proton, there will be common ion effect, and according to the Le-Chatterley's principle, it will try to shift the equilibrium in such a way that the added amount, the changes due to the added amount can be reverted back. So what we are doing, we are adding an acid, or you can say you are adding some product. So as soon as you increase the concentration of product, your equilibrium will shift in the backward direction. So that is happening here. When a little acid is added, the above equilibrium is shifting to the left hand side. Alright, so this is the reaction that will happen. Your acetate ion will react with proton to form acetic acid. Alright, now if a small amount of base is added to this solution, what will happen? That base will react with your acetic acid to form acetate ion and water. Alright, now we come to the basic buffer solution. Basic buffer solution is used to maintain the pH between 4 and 7. It can be prepared using a weak base and its conjugate acid. Let's see the example of ammonia and NH4Cl, ammonium chloride. So in an aqueous solution, ammonium chloride is a salt, so it will dissociate into its ion NH4 positive and Cl negative, and ammonia on undergoing hydrolysis will provide NH4 positive and OH negative. Now if you add a small amount of H positive, what will happen? your ammonia. This ammonia will consume the H positive and form NH4 positive. So on addition of acid, your equilibrium will shift in the forward direction. And if you add a base, what will happen? Your NH4 positive, here I have written it here, NH4 positive will combine with OH negative and form ammonia and a water molecule. This water molecule will not be present in the form of H positive and OH negative. It will be a complete water molecule. So what is happening? Your OH negative, the base you added to the solution, that will be consumed and there will be no change in the pH of the solution. Alright. And similarly this we have already discussed. So this way your acidic and basic buffer solution work.